For this skill, we were first asked to assign 5 different values, 3 of which, A, B, and C, all had to be a part of the same Pythagorean triple, so I just did 3, 4, and 5. And then it also told us the important information of tangent theta equals 4/3 in this case, which is about 53.3 degrees. And that will be important later when we're finding the rotation of the conic that we're going to find. So it also gave us like some important information like where our center was, and then the vertices, and then it told us that one of our foci had to be at 0, 0. So with this information, I can build my rectangular form of the conic. So I have x minus 6 squared over 7 squared, and it's 7 because this distance from here to here is 14, and 14 divided by 2 is 7, and that goes in this value right here. And the distance from covertice to covertice is 2 root 13, so it'd be just root 13. So root 13 squared is just 13, so that's why that's that. Now I can take that and put it into polar form, which would allow us to represent like visually in the equation how much this conic is being rotated by. So to do this, I had to find eccentricity first. So to do this, I have c squared minus a equals a squared minus b squared, and that gave me 6. Excuse me. So I have 6/7 as my eccentricity, and then that's also equal to point to focus over point to directrix. So it'd be 6/7 is equal to 1, because in this case, this is 1 to 0, it's distance of 1, over PD, and PD ends up being 7/6. And now to find K, you have to add that 1, because this is already 1 to the left of the origin. To find the actual location of the directrix for this, you have to find point to directrix plus that extra like distance that's already happening. So it'd be plus 1, which is K equals 13/16. Now you can put this into this equation over here. Where did I put it? Oh, right here, sorry. So it's R equals 6/7 times 13/6 times 7, because I'll explain that later, over 1 minus 6/7 cosine theta. So the reason you're multiplying these by 7 is that if you get rid of this 7 right here, this becomes 6 times 13/6, which then cancels out to just 13, and then this becomes 7 minus 6 cosine theta, and then you'll subtract 53.13. It's like in a sine graph, how like if you have x minus pi over 2 or like something, how it determines period and frequency, and how if it's like at pi over 2 you have to use minus, and so if it's negative pi over 2 you would have to use plus. It's the same like deal here. So that's just showing that it's rotated counterclockwise 53.3 degrees. And multiplying by 7 just cleaned it up and made it a lot prettier, and gives us R equals 13/7 minus 6 cosine theta minus 53.13. Now for the next part, I have to use these two equations right here, which represent the rotation of the axes. So to do this, I needed my cosine theta and my sine theta values, which I found to be -4/5 and 3/5. So 3/5 for cosine and -4/5 for sine. So then I plug these into here and get x equals m 3/5 plus n 4/5, and then y equals m 4/5 plus n 3/5. Now I can take these equal to x and equal to y and plug them back into my original rectangular form over here. And then I have to expand all of this, and then it's just a lot of ugly algebra. So it'd be m 3/5 plus n 4/5 minus 6 squared. So you get all this math right here. And then it'd be negative m 4/5 plus n 3/5 squared, and you get this math right here. And once it simplifies, you would add it to this math, and you end up with this ugly, grotesque, and just dumb long equation that just simplifies down to this, which is 36.04 m squared minus 34.56 mn plus 25.96 n squared minus 93.6 m minus 124.8 n minus 169 equals 0. And when you graph that, that's actually the exact same graph as this right here. This is just like a different way to represent the rotation of the conic.